Welcome. We're going to look at the fundamental counting principle and permutations and combinations right now. Let's start with the fundamental counting principle. In a party, you can choose from 4 flavors of ice cream and 6 toppings. How many choices do you have? You may only have one of these and one of these. Well, very simply, that's simply 4 times 6, so it's 24. And that's how easy that this is. And you simply multiply how many you can have of something and how many of another. The reason why, think about it, is that you have 4 flavors of ice cream. So for the first flavor of ice cream, you have 6 choices. And then for the second flavor of ice cream, you have another 6 choices, but even though the choices are the same, because the ice cream's different, it's 6 completely different results. So say vanilla ice cream and 1 topping, or chocolate ice cream and the same topping, but those are still different things even if the topping's the same. And then when we do a third one, and then 6 of them, so this is 6 here, then that's 12 total. Now there's 18 total. 2, 3, 4, 5, 6, and now there are 24 total. And that's the same as simply multiplying the 4 times the 6. So when you recognize that it is a simpler one with this, you just simply multiply. We're going to do the same type of thing here. 7 students are assigned to make presentations. Temporarily ignore this. 1 is not going to be away yet. How many different ways can these 7 people be ordered? Well, let's think about it if it was 7 people in a classroom having to make the presentations. And so one of them is picked, and that person picked first to choose, and that person decides to do it, or rather they get their choice. They get 7 choices. Then they sit down, the next person gets to choose, but there are 6 choices left for that person. You see, 1 choice has been taken off the table because someone went before them. Now the third person stands up, makes their choice, but they only have 5 possibilities because 2 of the 7 are gone. And then 4 and 3 and 2. And the last person stands up and they only have 1 choice, just the one that's left. Well, when you multiply all of that out, that's going to be, let's see, 720 times 7 is 4920, I think. Hold on. Nope, it's 5040. 5,040 different ways that they can be ordered. But now let's add this in. 1 goes last automatically. So something sort of like the person has a special thing they have to do on one day and they can't be there, so they have to do it the next day, or as a last one on a different day. So they would go last automatically, which means of the 7 possibilities, 3, 4, 5, 6, 7, that one's already done. So now when the first person who's left stands up and they make a choice, there's only 6 possibilities waiting for them because one's already off the table. And now when the next person stands up, they have 5 possibilities because 2 of the possibilities are gone. And 4 and 3 and 2, and it happens that there's 2 ones. So multiply these and you get 720 possibilities. That's a big difference just by 1 number going left. But that's what the multiplication shows. And if you were to figure them out individually, you would find that's what it would be, 720 or 5,040. Okay, let's see if I can get good. Got that in there for those possibilities, showing that difference. Now, let's look at what permutations and combinations are. Permutations is when there's a specific order of something, sort of shown by the thing down here. Oh, enter. I need to write the words in a competition. So if 9 students enter a competition, the first, second, and third place matters. So if student A is first and student B is second and student C is third, that's not the same as if student B is first and student A is third and student C is actually second. That's a different result. In a combination, which is farther down the page, the order doesn't matter. Sort of like in this example now. 9 people are standbys waiting for an airplane flight, but only 3 seats are available. How many ways can 3 of the standbys be chosen for the available seats? Well, here, whoever is the first one chosen for a seat, it doesn't really matter as long as they get one of the 3 spots. So if person A is first and person B is second and person C is third, that's 1. But if person B is first and C is second and A is third, that's still that same one. It's still the same group of 3. The order that they're chosen doesn't matter as long as they're in that top 3. And that's going to make a difference in the calculations. So let's look at how these calculations are done. So these are symbol or ways of showing it, and also can be shown this way, A and B. What this stands for is the A is the total number of things that you have, sort of like 9 students. And the B is how many things are being chosen. So this would be 9 things, 3 chosen at a time. Nine things, 3 chosen at a time. So that's P, oh, well, actually, then that means this one's going to be P 9, 3, or P with a 9 and a 3, or P 9, 3. Well, let's first do it with 7 and 4 here. Okay, so I can write that as 7, not with the slash though, just with 7, 4, equals 7 and 4 equals P 7, 4. Now, this is the formula. A factorial in A minus B factorial. So that's 7 factorial over 7 minus 4 factorial. And you can do this, and that's 3. That means that's 3 factorial. You can do this on a calculator with a calculator button. Do math, and I think it's the math button. I'm going to check. And then probability. Usually, the math button, move to probability, and then it's the 4th thing down the page. So I'm going to do it out by hand though. 7 times 6 times 5 times 4 times 3 factorial, and 7 minus 4 is 3, so it's 3 factorial. Now 3 would be 3, 2, and 1, but right now I can just cross out the 3 factorial because they're the same. And then when you multiply 7 times 6, 7 times 6 times 5 times 4, that's equal to 840 for that number. So 7 things taken 4 at a time, and the order matters in them, then there are 840 possibilities. We can do that now down here with 9 people enter the competition. How many possibilities are there? So that's going to be 9 factorial, and then 9 minus 3 factorial. So 9 times 8 times 7 times, times 6 factorial. On the bottom, 9 minus 3 is 6, so 6 factorial. So 6, 5, 4, 3, 2, 1, 6, 5, 4, 3, 2, 1, they just cancel out there. And 9 times 8 times 7 is 504 possibilities. So over 500 different ways people can be moved around or ordered around, put in the right order to get a first, second, and third place award. Now let's repeat this with combinations, and there's only one difference in the calculations, and that's this here. We add to it the B, the number of things being chosen, as another factorial. So let's work this one out with here. 7 factorial, 7 minus 3 factorial. Oh, it's a 4. I was jumping ahead in my head thinking of the 4. Or the result. And then 7 take away 4 plus then the 4 factorial. So on a calculator to do that, we're calling this one 3 factorial. So what I'm going to do is 7 times 6 times 5 times 4 factorial, 3 times 2 times 1 times 4 factorial. So this factorial and part of the 7 will go away. And also 3 times 2 makes 6, so that goes into 6, so that's 35 for the possibilities. Now, let's look at something. For combination of 7 things taken 4 at a time, there's 35 possibilities. Well, combination of 7 things taken 4 at a time as a permutation is 840. So we have 840 and we have 35. And that's a pretty huge difference here. Okay, so, and that's because for each one of the combinations, there's like 6, 7, 8, a whole bunch of possibilities that would be separate permutations. Okay, times 5. Now let's do it with this application here. 9 people, standbys, only 3 seats are available. How many ways can 3 of them be chosen? So this is a combination of 9 things taken 3 at a time, or I can do C 9 3, or I can do C 9 3. Either way, I'm going to get 9 factorial over 9 minus 3 factorial, and then 3 factorial. So since 9 minus 3 is 6 factorial, 6 there, going to have 9 times 8 times 7 times 6 factorial. And underneath it, 3 times 2 times 1. Oh, and the 6 factorial. That covers this, and then a 3, 2, 1 for the 3. And that's because, for calculation-wise, the 6s and all the ones after can go away, but the 3 and the 2 are a separate part from the 6 factorial. So in this, there's no 6 above there, but the 3 can go into the 9 to make it a 3. The 2 can go into the 8 to make it a 4. And that comes to a total of 84 possibilities. Now, this is especially interesting. There are 84 possible ways that 3 out of 9 people could be chosen when the order doesn't matter. But when it does matter, like up here, the 9 students, and these 3 things being taken, same type of problem, even though it's set up, sounds different, it's really the same math in it. But this one, there's 504. Okay, when the order matters, it's 504. When it doesn't, it's 804. And that's a multiplying of, actually, I don't remember, 484. Let's calculate that. 6. And that's because 1, 2, 3, well, 1 times 2 times 3 is 6. So since the order matters, for every one of the combinations, there are 6 possibilities, for 1 here and 5 more. And that means that you have 504 total instead of just the 84. So watch for this difference between permutations and combinations, specifically when the order matters and when it does not when it does not matter. Well, thank you for watching and listening. I hope this was helpful to understand the basics of this, as well as the differences between the permutations and combinations.